Hello students, today we will start our fourth chapter, the physical layer. Here the physical layer is concerned with transmission that you have already known. These transmissions of the raw bits over the communication channel, and these specifies the mechanical, electrical and procedural network. Here these interfaces, specifications and the physical transmission of bit stream over a transmission medium which is connecting to two pieces of communication equipment. Then these are the contents for physical layer: introduction, then basic concept of signals, then transmission impairments, then performance of network, line coding, transmission mode, multiplexing and switching techniques, and physical layer devices. Then first introductions for physical layer. The physical layer in the OSI model plays the role of interacting with actual hardware and signaling mechanisms. The physical layer is the only layer of OSI network model which actually deals with the physical connectivity of the two different stations. This layer defines the hardware equipment, then cabling, wiring, frequencies, pulses, which is used to represent the binary signal, etc. The physical layer provides its services to data link layer, then data link layer hands over frames to the physical layer, and the physical layer converts them to electrical pulses which is represent the binary data. The binary data is then sent over the wired or wireless media. To be transmitted here, data must be transferred to the electromagnetic signals, and then it is layer which is actually interact with the transmission media which contain network components together. The physical layer also involve physically carrying information from one node into the network to the next node. Then the here physical layers performs sometimes complex tasks, and it also provides services to the data link layer. The data in the data link layer is organized in 0 and 1 in smaller frame. These streams of 0 and 1 must be converted into the signal. The physical layer also take care of transmission medium, and it must be controlled by it. Then some basic concept of the signals. Here signal having analog and digital signals, but here also analog and digital data is over here. Data can be analog or digital, and analog data are continuous values. For example, human voice, analog clock, then minute and second hands given informations, etc. Then digital data have a discrete state and take discrete values. For example, data stored in computer or digital clock, etc. But here is analog and digital signals. These signals can be either analog or digital as shown in this figure. See, this is the figure for analog and digital signals. Analog signal has infinitely many levels of intensity over a period of time as wave moves from value A to value B, and it passes through and includes as infinite number of values its path. Then digital signals on other hand can also have a limited number of defined values, although each values can be any number. It is often simply 1 and 0, and analog signal can have infinite number of values in range of digital signals can only have limited number of values. See, this is the figure. Here these are the here values, and these are the times. This is the analog signals, that means it defines infinitely many levels of intensity. Then here digital signals, it having a square shape and 0 and 1, it defines only limited number of values, that means 1 and 0. Then a digital transmission has advantages over analog transmission in following ways. First is a digital signal can pass through number of repeaters without loss without loss of the signal, and so travel long distances without loss of data, whereas analog signal lose the data when amplified. Then higher data rates are possible in digital transmission by using existing lines which is not in analog. Then in digital we can integrate voice data, video and music. Then it is easier to multiplex large channel capacities with digital. Then easy to apply encryption to digital data. Then maintenance is easy in digital transmission than analog. And nowadays the cost of digital equipment and the size is continuously reducing. So digital transmission becomes cheaper than the analog. Here the difference between analog signal and digital signal. In analog signal is continuous signal which represent physical measurement. Then in digital signals are discrete times signal which is generated by the digital modulations. Then waves, it is denoted by sine waves. These waves is called as the sine wave. Then these signals is denoted by square waves. See this figure, this is the square waves. Then representation uses continuous range of values to represent the information. Here uses the discrete or discontinuous values to represent the information in digital signal. Then here example for analog signal, human voice in ear, analog electronic devices. Then example for digital signal, computers, CDs, DVDs and other digital electronic devices. Then flexibility, in analog hardware is not flexible, but in digital hardware is flexible in implementations purpose. Then uses can be uses in analog devices only, best suited for audio and video transmissions, but in digital it is best suited for computing and digital electronics. Then applications, analog signal applications is thermometer, and in digital signal it is like PCs, PDAs, etc. Then power, analog instrumentations draws large power, then digital instrumentation draws only negligible powers. Then cost, analog signal cost is low cost and it is portable, but the digital signal having cost is high and it is not easily portable. Then impedance, in analog signals its impedance is low, but in a digital signal its impedance is high. These are the difference between analog signal and digital signal. Then next topic is periodic and non-periodic signal. Both analog and digital signals can take one or two forms like periodic and non-periodic. Here the data communications we commonly use periodic analog signal and non-periodic digital signals. Periodic analog signals, here a simple periodic analog signal is a sine wave which cannot be decomposed into simpler signals. Then a composite periodic analog signal is composed of multiple sine waves. A sine wave can be represented by three parameters. First is amplitude. The peak amplitude of signal is the absolute value of its highest intensity proportion to the energy it carries unit volt, and its symbol is capital V. Then second is frequency. Frequency is the number of cycles per second and its inverse is time period T and unit is Hertz, Hz. Then third is phase. It gives a measure of the relative positions in the time of two signal within a single period, and units is degree or radians. See, this is the sine wave and it having frequency is the number of cycles per second, and it is inverse is time period. So that means f is equal to 1 upon t, and the unit of frequency is hertz. Then second is it having phases, and it gives the measure of relative positions times in degree signals. Then second type is a non-periodic signal. Informations can be represented by a digital signal. For example, one can be encoded as a positive voltage and 0 as negative voltage. A digital signal can have more than 2 levels. In this case, we can send more than 1 bit for each level. In general, if a signal has a L level, each level needs log to L bits. And see, this is the figure. This figure is having digital signal with 2 levels, and figure B shows the signal digital signal with 4 level. See, this is the diagram. It contains a digital signals with 2 levels. See, this is the level first and level second. This is the amplitude, and this is the time. Then here we passes the signals, one with 2 levels and the other with 4 levels. Here this is the 8 bit sent in once, and bit rate is 8 bps, bits per second. Here this level first it having level 2, so the bit passes 1, here 1, then 0, 1, 1, 0, 0, 0, 1. This is the 1 second. A digital signal with here 2 levels. Suppose this is the example 1, 0, 1, 1, etc. That means here 1 means positive voltage and 0 means negative voltage. Then we will see the 4 levels example. This is the this is also here amplitude and time, and here is also 1 for positive voltage and 0 for negative voltage, and here level 4. When level 4, then it having bit rate is 16, and here the bits are 1 1 2 levels, that's why 1 1 1 0 0 1 etc. These are the digital signals with 4 levels. Then for example, a digital signal has 8 levels, then how many bits are needed per level, and we calculate the number of bits from the formula. When the levels are 4, then how to calculate the bits are needed per level? Here the formula for log to L, here the log 2, and L for level, here the level is 8, so log to 8 is equal to 3. So when it having 8 levels of signal, then its bits is 3 and its bit rate is 24 bps, and each signal level is represented by 3 bits. Then digital signals. A digital signal used to represent the data. Most digital signals are non-periodic, and thus period of frequency is not appropriate. Two new terms, bit intervals and bit rate, are used to describe the digital signal instead of period and frequency respectively. Here the first is a bit interval. The bit interval is the time required to send one single bit. See, this is the bit interval. Here amplitude versus time. This is the bit interval. Bit interval is the time required to send one signal bit. Then second is bit rate. The bit rate is the number of bit interval per second. That means here the bit rate 8 bit per second. BPS stands for bit per second. And this means that the bit rate is the number of bits sent in 1 second, and usually expressed in bits per second, that means BPS, as shown in this figure. Then bit length. For analog signal, The distance one cycle occupies on the transmission medium is called as the wavelength. And similarly for the digital signal, the bit length is used, and the bit length is a distance one bit occupies on the transmission medium, and calculated by the bit length is equal to propagation speed into bit durations.